Okay, so today we're going to do the final element for this Spar web. So this is the flanges, this is your cantilever, and this is the web, the panel. And on the previous video or lecture, we studied that we have two different cases. First one is when we assume just the panel, just to carry shear, and the option 2 would be that this panel can sustain shear, but also some of the bending moment due to this force over here. Okay, so how do we do the modeling? So there's two different type of elements. So let me go to this page. So basically for the FEMAP Nastran, case 1, web does not carry any bending stress, then we need to do the modeling of the web or the panel using shear element and the flanges with rod elements. Okay, for case 2, where we have the assumption now that the web or panel can carry bending stresses, we need to select an element that can carry bending stresses, and that would be to select a plate element. Okay, and for the flanges will be the same thing. The problem here is that one of the output given by the problem is not shear, but we know by definition that shear is what? Is shear stress times the thickness. Okay, so basically in order to get the shear flow from the shear stress, you need to multiply the shear stress by the thickness of the panel. That's what I'm saying over here. All right, so let's get started. If we go back over here, we see this is, let's work in millimeters of 400, 200, and that would be 2000. So it looks like we need to create 1, 2, 3, 4 points. Okay, so let me start here, FEMAP. All right, so let's see, geometry points. So we can do, let's say, minus 200, and then at 2000, minus 100, and here will be 100. All right, Control A to center the point, so that looks about correct. So now we need to create the shear panel over here. So let's do geometry, surface, corners, method on point. You select one point at a time. Okay, there we go. Cancel. So that's basically the geometry. So let's save this file, save as. Alright, I'm using this Nastran. So this would be new folder, let's say Nastran 5. Here we go. And let's call this one model 0. I like to save on the way, that way if you need to, you don't need to restart from 0. Okay, so on the example, if I remember right, we did for case 2. Okay, so that means that in this video we're going to use plate elements and rod elements. So let's go to model, material. Let's use, let's say it's 2024, so 75 to the 9.3. So this is basically like would be like aluminum 2024, but it doesn't matter because we don't calculate here displacements or rotation, so really the material is not important. You can put anything you want, you can put 1. Okay, cancel. So model, property, double click to make it active, property, right click, new. So this is the plate element already. So let's see what's the thickness, 2 millimeters. So I work in everything in millimeters, so this will be the average, 2 millimeters. So let's say plate t equals 2 millimeters. And okay, cancel. So next thing we can do now is create the other property, new element property. We need the rod. So here for simplicity, I'm just gonna put 1. And okay. Oops, no, we had a we have an area for those booms. So I think that he won't go to the rod element. Sorry for that. I think we are here 400. So all right, so let me go back here. You can right click, edit, and change this one by 400 millimeters square. Okay. All right. So now we can go and do the meshing. So let's say mesh control size on surface. So problem is here. If we do 10, would that be a lot? Would be 200, would be 20, and 10. Too much. Okay, so let's say 50. Okay, that's still a lot, but I can live with it. Why is it so small over here? Let's try 100. Really doesn't matter. I mean, you can go and refine later on. Let's do. I mean, let's see how it looks, and we'll see what happens. So mesh geometry surface. Okay, quad with plate elements. It looks okay. So there we go. If you want here, then we can go to mesh geometry curve. We can mesh this one, this one, this one. Really, you don't have to do this one, but if you want, you could do this one. All right, with the rod property. That's correct. Okay. Tools. Check. Coincident nodes. Select all. Okay. Preview should be all the edges. Done. Okay. So now we need to go to model, constraint. You can do normal or on curve. Let's do on curve. So we know this is clamp or fix. Clamp or fix over here. Okay. Okay. All right. Now we can need to apply the load over there. I mean, I would like to create a spider web and connect it over here, but for this case, just for simplicity, let's just apply the load here in the middle. But personally, I would like to see all 4 elements to be deformed the same way. So model, load, normal. Let's just do this one. So this is the F equal to 20 kilonewtons. Okay. So let's select this one. Would be better if we just combine all this one into one node over here, but should not be that bad. Minus 20 exponential 3. And okay. And click here now. Cancel. So you don't have to do this. File. Rebuild. Yes. File, Save As, Model 1, Save. Okay, so in this problem here, let's see if I remember right, we need to calculate here the section of 1. So 1 is right in the middle. We could do this later on, but so tools, work plane, say throw yes for now. So this is 1000. Let me just create a group here, new, let's say here, section AA at 1000 millimeters. Okay, so now this one should be active group elements ID, and basically will be an average, but we need to take these ones basically here. Okay, so the more you refine the mesh, better the result will be, but as a first run, let's just do this one here, and okay, because we need to check the values over here. Okay, and I think that's it. We can go now and run the analysis. You can just go to the little gear on top, create, new. This is static analysis, okay, and analyze. Hopefully we're not gonna have any error. Okay, so here we go. So let's remove now this work plane. Okay, and let's see what happened with the values. All right, so if we look at this section, so F5, let's do contour, deform, and let's look at the shear. So this is bottom, should be top. It doesn't matter which one you use. Top, XY, shear stress. Okay, okay. So you see here, if we combine, probably would be better, but since we're doing here the calculation, I think should not affect much the result. But if we were really seeing what would be the shear here, the way you apply the load, we probably may have some effect. So let's see what happened at the cut. Right click, show active group, and you see I have about 25.49, which is not really the result that we had, which is, and basically should be, if you multiply this by the thickness, it should be about that. So let's see what we had. You see about 50 to be the maximum value, and this because the web can resist a bending is not constant, so it should be like some type of distribution. Okay, so you can see it here, it's not constant, this is this, but if you do F5 and look at the criteria, they should give you more the values. All right, so it would be about 40, this would be about 50, so this is 39. This will show the distribution like being like this, no, like from here is kind of constant, and then it will be something like this. Okay, so we need now to see how we can do to multiply the output by 2. So let's see how to do this. So I think it's model, output, process, here linear combination, and we're going to multiply by factor of 2. And now we need to select the output process. So it will be this one. But I don't want the whole output process. I would just like to be able to select the plate shear. So let's see. Okay, let's see what happens. Okay, where are the outputs set? Okay, so this looks like it's gonna multiply everything. Let me do a reset here. One more. Oh, there we go. This is what I wanted. So plate top XY shear. So just this one for now, because really the displacement should not be multiplied by 2, just the shear flow. I want to do this one, okay, and click OK. And now let's see if one results. All results, so you have the combined, it should be this one. Let me go to groups. Okay. So let's try to see what happens here. So let's go to F5. Deform, let's see, contour, data, deform our contour data. Alright, so I'm not sure here what's happening. Okay, so this was multiplied by 2, and let's see at the cut. Alright, there we go. So at the cut now you see it's about, this is 51 or 50 over here, and it goes to the blue. If you want, we can do this for criteria. So basically now this should compare to this one over here. So about 40, 50, and we should see the load distribution, okay? And this is what we had for this problem. Yeah, that's the last page. Okay, so that's basically the final element for this. Okay, so I will stop the video, and then on the following video will be very similar to this one. I will just do one for case 1 after we do the analytical solution. So I'm going to stop the video over here. Let me see if I can close this.